So let's talk about imaginary numbers. Imaginary numbers are represented by the letter I. I to the first, second, third, and fourth power will be all the i's that you would need to know in order to solve for any I raised to a power. This is because the I has a pattern of fours, which means everything is divisible by 4, and whatever your remainder is, that's what you're looking for. So this is going to help you find the answer. So for instance, I to the first power is simply itself, I. I squared, you will just have to know, is -1. I cubed is the same as taking that I to the first power, which is I, and multiplying it times I to the second power, which is a -1. I times -1 is -I. And then if I took I to the fourth power, and I just took 2i squareds, because remember, with exponents you add them 2 plus 2. That's the same as saying -1 times another -1, which is a +1. So my pattern will always be I, -1, -I, and 1. This is helpful because, again, if I am looking at example 1, I wouldn't want to try to count out 100 i's. So what I want to do is take that exponent 100 and I want to divide it by 4. Long division is best. So if I take 100 and divide it by 4, I'm thinking about money. So I have $1 and I have 4 quarters, so that means that I have 25. I do not have a remainder. So that tells me that I would be I to the 0. Anything raised to the 0 power is simply 1. So this would be the answer if you saw I to the 100th power. So again, you could just divide this by 4 in your head, and then this is the exact same thing as I to the 0 power. I to the 13th, if I were to take if I were to take 13 and divide it by 4, doing long division, I know 4 can go into 13 3 times, and if I multiply 3 times 4, I have 12. My remainder, this is what I'm looking for, this right here, 1. And I'm just going to write a little I, because that tells me that I to the 13th power is the same as I to the first power. So if I go back to my chart, at the top, I would see that I to the 13th power is really I. That's how the patterns of 4 work. Again, you divide by 4, and you're looking for the remainder. That's what's going to give you your answer. So, if I am trying to take the square root of a negative number, how many of you have actually tried to do that? Try it now. Go ahead in your calculator and type in the square root of -1 and see what happens. What happens is you're going to get an error because it's not a real number. It's imaginary. So whenever you see a square root of a negative number, square root of -1 is automatically I. So if I wanted to work backwards, I would do my inverse. So remember, if you have an addition problem and you want to do the inverse, you would subtract. If you have a multiplication problem and you want to do the inverse, you would divide. I was about to do long division. Hold on, you would divide. If you have a square root and the inverse, you're trying to get rid of it, you would square it. So that's what we're going to do here. So I want to do, I want to take the square of the square root of -1. What I do to one side, I have to do to the other. And what that does is this square gets rid of that square root. So now what's left over is what's under the radical, which is -1 equals I squared. So if I rewrite that and I switch them around, this is what I said a few minutes ago. I squared is -1. So I just did the inverse of what I know to be true. Anytime I see a negative square root, an I has to come out. So let's look at example 1. So for example 1, I have a negative sign. So I'm going to factor that as an I. For the square root of 16, it's a perfect square, so 4 times itself. Square root simply means I need 2 of the same thing to come outside. Well, there's already a 2 out there. So whatever is outside already, I have to multiply it times that pair. So 1 set of 4, and I'm also going to bring out the I. So everything is out from under the radical, and now I just simplify it. 2 times 4 is 8, and then I. It has to be in the form with the I after. You would not write it as I8. That is incorrect. Alright, so we don't want to do that. Make sure you put your I after the number. If I had an example where there is not a number on the outside, I still have the negative sign, which is I. And then if I'm factoring, this is not a perfect square. Let's see what I can work with. Since the 12 has a square root on the top of it, my factors, for me, I'd rather just go ahead and show the square root as well. Because that way I can see if I can further simplify it. And in this case I can. Square root of 4 is actually 2 times 2. So I know that can go outside. And I know that I is going to go out. Square root of 3, I can't do anything with it, so it has to stay under the radical. So when I rewrite my answer, 2i goes outside, and then radical 3 is left over. This is how I write my answer. Some people may write it as 2 radical 3i. And notice you see a big space between the radical 3 and the I. This is acceptable as well. What is not acceptable is 2 radical 3 and then the I is under the radical. That is not correct. So to avoid that, I just use this that way. But just know, like on a test, you may actually see it written this way because, let me put my radical back, because it's in the BI form that you're about to see on the next slide. So, complex numbers. Complex numbers come with 2 parts. The first part, A, is the real part. The second part, BI, has the I with it, is the imaginary part. And let's say if we're adding complex numbers. So I've given an example, so we can just go ahead and start working from here. What I would do if there is a plus sign, pay attention to that, because typically kids will try to do FOIL or multiply this out. This is no longer multiplying. I know we were just factoring, but that's not what this is. This is adding. You're adding like terms. So if there's a plus sign, the signs stay the same. Vertical math is typically better and easier for some students. So I'm going to take this -5 and I'm going to put it under the real number over here. I'm going to take the positive 6i and I'm going to move it over to the imaginary part. Now I can clearly see that I am adding 3 plus -5, which is -2, and then 2i plus 6i, which is positive 8i. So this is my answer if I am adding a complex number. If I am subtracting, I have to remember my rules. So my rules would tell me that this is actually a -1. And when I have a -1 next to a set of parentheses, that tells me that I have to change the sign of everything, every term within the parentheses. This becomes a positive. This becomes a positive. Because again, -1 times -4 is positive 4. -1 times -7i is positive 7i. So now I can do what I just did, and I can get rid of this so that won't confuse me, and I can set it up to do vertical math. Positive 4, positive 7i. You do not have to do vertical math. Some people just see it better this way. Alright, now if I do my math, I have -2 plus 4, which is positive 2. 5i plus 7i is positive 12i. That's my answer. Notice again, it is in the correct form, A plus BI.